Now, our next question is related to a simple circuit diagram, which is explaining the production of amplitude modulated carrier wave. So, we are referring to not simply amplitude modulation, but it is amplitude modulated carrier wave. So, modulated carrier wave, again, we are referring to the mixing of two signals, and we have to vary its amplitude. So, what is the mechanism? The production of amplitude modulated carrier wave. The amplitude of an amplitude modulated carrier wave increases or decreases in accordance with the instantaneous value of the modulating or the message signal. So, message signal means the audio signal, and modulation means the signal in the form of electrical signal superimposed on the carrier signal. That is called modulating or the message signal. A simple circuit for producing the amplitude modulated wave is shown in the figure. So now we come towards the figure. Now a figure is shown, that is circuit for an amplitude modulator, that is the base modulator. Now we are finding one of the part in the modulator is C, that is a capacitor. And the carrier frequency is AC cos omega CT, that is called input. So input carrier frequency or input carrier wave is AC cos omega CT, and it is passing through the capacitor where its energy increases. Then there is RB, that is the load resistance. Load resistance is a high resistance, and there is a base battery, and then we are getting from that signal AM cos omega T, that is the modulating signal. So first is the carrier signal, and then where the arrow is indicated, we get a modulated or modulating signal. Shape of the modulating signal is indicated. Then in the circuit, there is a transistor right in the line of capacitor. If we further see, there is a transistor, that is NPN transistor, and that is connected to an inductor, or we can say it is connected to a transformer, and VCC stands for the carrier current, that is the battery current. So output is indicated from the load resistance where another capacitor is indicated. The output modulated wave is shown, in which the amplitude at the various points will be more or less. The circuit shown in the simple CE amplifier, that is collector emitter amplifier. The amplifier is also either PNP transistor or NPN transistor. So circuit shown in a simple CE amplifier, that is CE stands for collector emitter amplifier for the carrier wave signal. The carrier wave signal, wherever we use the term signal, we are referring to wave. The carrier wave signal, the modulating signal MT. What is MT? The modulating signal, and that is equal to AM sine omega MT is applied on the base. Thus the base biasing voltage is not constant DC, but is the sum of constant DC voltage plus or the voltage of base band, and modulating voltage AM sine omega T. As the base biasing changes, the amplification produced also changes. The output voltage as shown in the figure is a carrier signal varying in amplitude. As I've explained earlier, the output is in the form of the varying amplitudes. At certain instants, the amplitude is more, and at many other instants, the amplitude is less. So this gives an amplitude modulated wave. Now our next question is related to the block diagram explaining the function of a receiver for detection of amplified or amplitude modulated wave. So receiver for the detection of an amplitude modulated wave. When we use this term detection, we are using a rectifier. The purpose of the rectifier is that when input is passed in the form of AC, then output comes in the form of DC. So receiver for the detection of an amplitude modulated wave. Figure shows the block diagram for a typical receiver used for detecting an amplitude modulated wave at the receiving station. So transmission is completed and now receiving station will get the amplitude modulated wave, and there we have to detect the amplitude modulated wave. The antenna picks up the modulated wave radiated from transmitter. Now it is shown, that is received signal and receiving antenna is indicated. Tunable amplifier, which we can where we can match the frequency of the waves, and IF stage. So here IF stage, then we find that the signal goes to detector where it gets rectified, and then rectified signal is passed into the amplifier and the output comes in the form of DC. So that output is in the form of a, that is high amplitude, and where the amplitude is more, the loudness will be more. So loudness is directly proportional to amplitude square. Now we find by a tunable amplifier, the signal is selected and unwanted signals rejected. Now unwanted signal is obviously the carrier signal that is rejected into the atmosphere, and for tuning we require the audible frequencies. So audible frequencies are amplified in the PNP or NPN transistor and then passed into the loudspeaker where the sound becomes loud. The loudness is always given in decibel. To facilitate the further processing, the carrier frequency is changed to lower frequency by a device called intermediate frequency IF. Now when we say that frequency is changed to lower frequency, we are referring to 20 Hertz to about 20,000 Hertz. That is what the meaning of this statement. Then the signal is fed to demodulator, that is detector. Demodulator means separating the audio frequency from the carrier frequency, and the carrier frequency is rejected back to the atmosphere, whereas the audio frequency is fed into the amplifier, so which recovers the message signal from the modulated wave. To further strengthen the detected signal, it is fed into the amplifier.